The purpose of Western blotting is to separate proteins on a gel according to their molecular weight. The proteins are then transferred onto a membrane where they can be detected using antibodies. Heat the samples at 95 degrees C for 5 to 10 minutes in a sample buffer containing a reducing agent, such as beta-mercaptoethanol. This results in linearized proteins with a negative charge proportional to their size. Place a gel into the electrophoresis tank and add a buffer, ensuring the tops of the wells are covered. The acrylamide percentage of the gel being used depends on the molecular weight of the target protein. Load a molecular weight marker into the first lane. Then load the samples into adjacent wells. All the samples should contain equal amounts of protein. Once all the samples are loaded, add running buffer. Place the lid onto the electrophoresis tank. Turn on the power supply and set the voltage recommended by the manufacturer of the gels and the gel tank. You should be able to see bubbles rising through the tank. Run the gel until the dye front has moved sufficiently down the gel. The next stage is to transfer the proteins from the gel onto a membrane. Membranes are usually made from nitrocellulose or PVDF. Remove the gel from the tank and carefully release it from its plastic case. Cut off the wells and the gel foot and place the gel into transfer buffer. Prepare the transfer stack by sandwiching the membrane and gel between filter paper and sponges. The membrane should be closest to the positive electrode and the gel closest to the negative electrode. Use a small roller to remove any bubbles between the gel and the membrane. Clamp the transfer case closed and submerge it into a transfer tank containing transfer buffer. Add water to the outer chamber to keep the system cool and put on the lid. Turn on the power supply to begin protein transfer. Time and voltage will require optimization, so check the manufacturer's instructions for guidance. Now that the proteins have migrated from the gel onto the nitrocellulose membrane, the protein of interest can be detected with an antibody. The membrane can be removed from the cassette and the molecular weight marker should now be visible. If required, the transfer of proteins can be confirmed by staining the membrane with Ponzo S solution. To prevent non-specific binding of the antibody, the membrane needs to be blocked. Pour blocking buffer onto the membrane and agitate gently on a rocker. Typically this is done using a solution of 5% milk or bovine serum albumin, BSA, for 2 hours at room temperature or overnight at 4 degrees C. The time and type of blocking buffer should be optimised, so check the datasheet of the primary antibody you intend to use for details. After the membrane is blocked, remove the blocking buffer and add the diluted primary antibody in the same solution. Incubate on a rocker as before. Typically, primary antibody incubations are for 1 hour at room temperature or overnight at 4 degrees C. Antibody concentration and incubation time will need to be optimised. Refer to the antibody datasheet for guidance. Pour off the primary antibody and rinse the membrane twice in wash buffer. Follow with 1 15-minute wash and 3 10-minute washes on a rocker. The wash buffer is usually tris buffered saline, TBS, or phosphate buffered saline, PBS, with 0.1% tween 20. Pour off the wash buffer and incubate the membrane in conjugated secondary antibody, which has been diluted in blocking buffer. Usually this is done for 1 hour at room temperature, but antibody concentration and incubation time will need to be optimised. Pour off the secondary antibody and wash the membrane as shown previously. There are several different systems for detection. If the secondary antibody is conjugated to an enzyme, incubate the membrane in the appropriate substrate before imaging. If the secondary antibodies are fluorescent conjugates, then you can move directly onto the imaging step. Imaging can be carried out with X-ray film or with a digital imaging system. Place the membrane into an imaging tray. Place the imaging tray into the imaging system. Exposure times will most likely need to be optimised in order to clearly detect the bands relating to the proteins of interest.